This lesson is for section 6.10. We're going to be solving log equations. Now in our previous lesson, you guys used log properties in order to condense and expand and evaluate log expressions. Today what we're going to be doing is taking all of those skills a step further and solving log equations. So you still need to know how to do everything that we did yesterday, and now we're going to solve equations. So when you're solving log equations, you're going to run into three main types of questions. The first type of question has a log on both sides with the exact same base. So if you do have logs with the same base on both sides, you can simply set your arguments equal to each other, and that's how you would solve. Now the second type of question has a log on one side, but on the other side is simply a number, some value. Now in this case you can make an exponential equation and then solve that exponential equation. So you just convert from logarithmic form to exponential form. The third type of equation is kind of disguised as, a more difficult question, but it actually ends up turning into a question like number 2, because even though the bases are not the same on both sides, one of the sides of the equation can be simplified to just being a number. So then it actually turns into a question like number 2. Okay, so let's begin with the first type of log equations where we have the same log with the same base on both sides. So our first example here is meant to be very, very straightforward. We have the log base 6 of x equaling log base 6 of 3. Because our logs have the same base on both sides, we can equate our arguments. So x will equal 3, and that's as far as you have to do, or as far as you have to go, because you've got x by itself. Now in number 2, we have logs all with a base of 3, so that's good, but I can't just equate my arguments quite yet. What I have to do here is condense the left-hand side first. So I write that as log base 3 of x over 2 to the 4th power. So I'm just using this and taking that 4 here, bringing that over here, and then writing this as the quotient of x over 2 to the 4th power. Now on the right-hand side I have log base 3 of 4, and because I have the same base now, I can equate the argument and say that x over 2 to the 4th, which is 16, should equal 4. So now I solve by multiplying by 16, and I end up with x equaling 64. Now in the third example, each one of these has a base of 10, okay? And in this case, again, I want to condense before I set my arguments equal. So I have the log of x plus 4 times x plus 6 equaling the log of 3. Now that I have the same base on both sides and I have just one log on both sides, I'm going to equate my arguments. So x plus 4 times x plus 6 should equal 3. So I'm going to FOIL here. So I have x squared plus, let's see, what is that, 10x plus 24 equals 3. And from here I'm going to solve this quadratic. So I have two solutions here. After I factor, x will equal -7 and x will equal -3. Now the thing I have to make sure I do though is to go back and always check my solutions. Okay. Remember, you can't have a negative argument or a negative base in a log. So when I plug in the value -7 here in for x, I end up with -7 plus 4. I have a negative argument here. So -7 will not work. However, -3 does work. If I plug in -3, I have -3 plus 4. This gives me a +1. -3 plus 6 gives me a +3. So -3 is a valid solution here for number 3. Okay, now our second type of example is when we have a log on one side and on the other side we have just a number. So here I have log base 4 on the left hand side and just 2 on the right hand side. So I'm going to simplify, or I'm sorry, condense the left hand side first and write that as log base 4 of 3x equals 2. Now in this case, students will often get stuck. They don't know where to go from here, but all you're going to do whenever you get stuck is switch forms. That's the best thing I can tell you. Anytime you get stuck when you're solving either an exponential or a log, is to switch forms and go with a different form. So because I'm in a log form, I'm going to switch to exponential. So I'm going to convert to exponential when I try to solve these types of equations. Okay? So I write this as 4 to the 2nd power equals 3x. So I have 16 equals 3x, divide by 3, and I have 16 thirds. Okay? Now in the second example, I have a little bit more complex question here because I have a quadratic. It results in a quadratic. So if I were to condense here, I'm going to keep that 3, or I'm sorry, bring that 3 here and make that log base 4 of 2 to the third plus log base 4 of x squared. So bring that 2 here. And then I'm going to condense further by making this the product of, this is 8 and this is x squared, so 8x squared. So we have log base 4 of 8x squared equals 2. And again, I'm going to convert this to an exponential. So I have 4 to the second power equals 8x squared. Now if I want to get x alone, I am going to divide by that 8 first. So I have 8, whoops, 2, my bad, 16 divided by 8 is 2, so 2 equals x squared. Now I'm going to take the square root of both sides. So I have x equaling positive or negative root 2. Now I want to check my solution to make sure that I don't end up with a negative argument if I plug something back in. And if I plug in negative root 2 back in for x, I do end up with a negative argument here in the original. So my only solution here, so I'm going to cross off that negative here, it should be x equals root 2. Now in number 6, there's going to be a little bit more work here to just condense it. So let's start by taking that 2 and raising negative x to the second power. So we have log base 5, negative x squared actually turns into positive x squared. And then I have minus, let's take that 25 and raise that to the 3/2 power. So log base 5 of 25 to the 3/2 power. Now I want to simplify this 25 to the 3/2 power real quick. I'm going to write that as 5 squared raised to the 3/2. So that's really 5 cubed, right? The 2's will cancel, so that's 5 cubed. So I have log base 5 of x squared minus log base 5 of 125. Now, even if I didn't simplify 5 cubed, let's write it actually as 5 to the third power, 5 cubed. Okay, now here I've got 2 ways that I can go about simplifying here. I know that this is equivalent to just 3, right? This is equivalent to 3. So I have log base 5 of x squared minus 3 equals negative 5. I can add 2 now, or I'm sorry, add the 3 now to this side to make that equal negative 2, and then I can solve from here. So let me erase here. Or I could take it a different way and say log base 5 of x squared over 125 equals negative 5. It's really, there's no difference here in how you solve this. I think this way is actually more difficult though, but I'm going to stick with this because I think that most students will see it this way. They won't necessarily recognize that they can reduce this to a 1 first, and then, you know, that's equivalent to just 3, and then add the 3. So I'm going to do it like this because I think this is what more students would do. Okay, now that I'm stuck, right, I can't simplify this any further. Now that I'm stuck, I turn this into an exponential. So I have 5 raised to the negative 5th power equaling x squared over 125. Now I'm going to write 5 cubed here instead of 125. Okay, now if I want to get x squared by itself, I would have to multiply by 5 cubed on both sides. So now that I'm multiplying by 5 cubed on both sides, I end up with 5, add the exponents here, to the negative 2nd power equals x squared. So basically x squared is equal to 1/25. Now I take the square root of both sides, or I could raise it to the 1/2 power, right? Either one. So I get 5 to the negative 1st power. This is 2 possibilities though, positive or negative, 5 to the negative 1st power. So x will equal positive or negative 1/5. Okay. Now when I go back to check these 2 solutions, because I do have 2, I need to make sure I plug them into the original. Now if I plug in negative 1/5 into the x here, I end up with a positive 1/5 here for the argument. So negative 1/5 actually does work. So x equals negative 1/5. And if I plug in a positive 1/5, I have a negative argument, right? This stays negative. So negative 1/5 is my only solution here. X equals positive 1/5 does not work. All right, now our last type of question that you're going to see is where you have 2 different log bases on both sides. So In this case, we have a log with a base of 3 on the left and a log with a base of 5 on the right. Now don't think that you can't solve this because the right-hand side here can actually simplify and become just a normal number. So we have log base 3 of x equaling 2 times the log base 5 of 25 is actually equivalent to just 2. So we have 2 times 2. So log base 3 of x equals 4. Now that we're stuck, right, because we can't simplify any further, we're going to convert this to an exponential. So again, when you're stuck, switch forms. We're in log form, so we're going to go to exponential form. So we're going to take this and write that as 3 to the 4th power equals x. So x will equal 81. All right, now number 8, let me erase this. Number 8, on the left-hand side, I want to simplify this or condense this and write that as log base 3 of x over 4, 2 squared, right? So x over 4 equals, on the right-hand side, log base 4 of 1/16 is actually equal to negative 2. So 4 raised to some power equals 1/16. So if I were to equate my bases here, this is 4 to some number equals 4 to the negative 2nd power, so that must be negative 2. Alright, so on the right-hand side, this whole thing reduces to negative 2. So I'm going to erase this. And now, again, that I'm stuck, I will convert this into an exponential. So I have 3 to the negative 2nd power equals x over 4. So my base here is 3, the exponent is negative 2, my argument was x over 4. And now to solve this, I need to get the x alone, so I'm going to multiply by 4. Well, on the left-hand side, this is 1/9, so I have 1/9 equals x over 4. Multiply by 4 on both sides, and you end up with x equaling 4/9. If I check this solution, this is a positive, it stays positive. Sorry, I forgot to check the last one over here. 81, plug it in, you still have a positive argument, so that one was good too. Okay, last question for the lesson. So on the left-hand side, I have a log with base 6. On the right-hand side, I have a log with base 3. So I'm going to work to simplify the left-hand side and condense this. So I have log of, with base 6 of 2x squared, so I'm going to make that 4x squared, plus log base 6 of 81 to the 1/2 power. So 81 to the 1/2 power is taking the square root of 81, so that's going to be 9. So log base 6 of 9 equals log base 3 of 27, which I will then simplify to equaling just 3, right? If I evaluate log base 3 of 27, that would equal 3. So on the left-hand side, I now have log base 6 of 4x squared times 9, so that's 36x squared. All right, now, let's write that a little bit closer. Now that I'm stuck, right, I need to convert into exponential form, so I'm going to rewrite this as 6 to the 3rd power equals 36x squared. Now I need to get the x squared alone, so I'm going to divide out 36 here, and when I divide that on the other side, I'm going to rewrite that as 6 squared. So I have 6 cubed divided by 6 squared, which is going to equal 6. So I have 6 equaling x squared. Take the square root, and we have 2 possible solutions, x equals positive or negative root 6. Now if I plug in that negative root 6 here, I have 2 times negative root 6. So this value will be negative 2 root 6, but in the original equation here, my argument won't be negative because I'm squaring this value. So even if I plug in a positive or a negative, this value here will always be positive since I'm squaring it. So both of these are actually valid solutions. So you want to be careful, always double check your solutions, and sometimes the negative will stay, so don't automatically assume that you have to throw out the negative. Okay, that's the end of the lesson. I will see you guys in class tomorrow. Be prepared to ask questions and solve a lot of log equations.